Okay, good morning, everybody. Thank you so much for joining us today. I'm actually coming to you live from Forum Next Forum here in Austin, so I apologize if there's a little bit of background noise, but we're really excited to talk to you today about 3D printing from CAD to fully printed parts in just 30 minutes. Today with us, we have Jasmine, who's one of our applications engineers, and she'll be doing the live demonstration for us. She'll get the print started, talk a little bit about our software and how you start a print with the ZiP Pro, or sorry, with the ZiP, and then we'll do a little bit of an overview of not just the software, but the technology, the printer, its capabilities, while we wait for that demonstration to wrap up. And then in just a few short minutes, you'll get to see fully printed parts with our ultra-fast LSPC technology. And with that, I'll go ahead and turn it over to Jasmine. Jasmine, are you ready?
I am ready. All right. Well, good morning, everybody on the West Coast, and good afternoon to everyone on the East Coast. My name is Jasmine, and I'm going to be hosting this webinar for you guys today. So I'm going to go ahead and get started by actually starting our print. So today we're going to be working with X45 Natural. It's one of our fastest materials on our ZiP desktop printer. And we're going to be printing out 30 connectors in just 10 minutes. So I'm going to go ahead and get that started. And then I'm going to take you through how I kind of went from CAD to part using our NexaX software, and then explaining a little bit more about that, and then a little bit about the printer. And if we have any questions at the end, I'm more than happy to answer them. So let's go ahead and get started.
And Jasmine, sorry, real quick, on that note, I forgot to cover with you guys. If you have any questions throughout the presentations, there's a Q&A box where you can enter that in, and we will answer them as we're able to live. And if not, we'll answer it at the end of the presentation. If you have any technical difficulties, please use the chat for that. I'll be monitoring it, and I'll make sure that we try to resolve that for you as quickly and as easily as possible. If you have any issues with audio and or like a lag in the video, much like the advice you get from IT to restart your computer, the best option here is just to close out of the Zoom and rejoin, and that usually solves a lot of problems. And sorry for interrupting, Jasmine, take it away.
We're all good. So let's go ahead and get started. I already have the print up, so I'm just going to go ahead and click start, and while that prints, I'll go over everything else. So while that's going ahead and going, I'm going to go ahead and share my screen. So I was a student at some point, much as many of you probably were. And when I started off with CAD softwares, I started off with SolidWorks and Autodesk Fusion 360, which are both amazing softwares, and there's a lot of them out there. So here I have a part similar to the one that I'm printing out right now. It is a three-way connector. And so whenever you design something in CAD, you are usually able to export your model. Usually if it's in SolidWorks, you can export it as a step file, but you can also export it as an STL. And I'm going to go ahead and show you how to do that today. The reason why we use STL files for our printer is because it's the most compatible file format for 3D printers. But rest assured, if you are a frequent Blender or ZBrush user and you like to be a little bit more creative, create figurines or something like that, our software also accepts OBJ as well as .3mf files. But today we're going to be showing you how to go from CAD part to print. So I have my part here, and I'm just going to go ahead and go to click on it. And I can always save my file as a mesh. So a mesh is essentially all of those triangular faces that create your part. So if I go ahead and click on Save as Mesh, it's going to give me a couple of options here. So you can see that I can select my part, and then I also have different formats that I could choose from. So there's 3MF, there's STL binary, and ASCII, and OBJ. So technically, any of these files can work. Usually if you go with STL, you do want to choose binary. It's just the most compatible format. So I'm going to go ahead and go with that today. And I do want to make sure that I am using the correct units. Sometimes if you export your STL file using incorrect units, you will see that later on when you import your file into NexaX. Usually it's a little wonky where it'll show up extremely big or extremely small. But no worries, we're going to go ahead and export in millimeters today. And sometimes you do have the option of sending your part directly to a 3D printer. So if you work with such as the M2s or one of the filament 3D printers, you can have the option of setting up your printers together. In this case, we're just going to go ahead and export our model. So I'm going to go ahead and click on OK. It's going to ask me to save it, and I'm just going to go ahead and click Save. I already have that saved from a previous webinar, so I'm going to go ahead and overwrite that. And this should now pop up in my downloads folder. So that's great. We're already one step ahead to creating our print file. So now I'm going to go ahead and open up NexaX. This is a little warning we get over here at NexaX for having an unlimited software. So when you go ahead and open NexaX, the first thing that happens is you get prompted with our job setting menu. So this is pretty much where you're going to just create a couple of adjustments, choose what kind of printer you want to use, choose the material, make any small minor adjustments that you feel like need to be made before going on and creating the actual build. So in this case, I'm going to go ahead and select our XiP desktop printer. And the resin that we're going to be using today is X45 Natural. So before I continue further with going over the software, I do want to point out a couple of things. So NexaX is our proprietary slicing software. So it is a requirement for creating print jobs on our printers. Aside from that, we also offer two versions of NexaX. We offer a basic version as well as a pro version. The basic version is free and available to all users online and can be downloaded and immediately used after downloading. But we also offer a pro version, which is an open platform system, and it offers a couple of additional tools, usually mesh editing tools. So this is for larger industries, bigger corporations, research, or anybody who wants to explore further into the resin realm. So today I'm going to be going over some of the basic features as well as some of the pro features as well to give you an idea of what it is that you can get out of our software while using it. So going back to the job settings menu, I have my printer selected. I have the material. Here we have a profile. I'm going to go ahead and use the default one. We have over 30 plus different materials here at Nexa. We offer anything from elastopolymers to rigids and strong materials, prototyping materials, and even biocompatible materials. So having said that, all of those materials have already been pre-validated on our machine. So all of the cure times, all the base exposures, even the motor movements have already been determined by our process team, which is why we have a default profile. But if you have the pro version, you can technically create your own custom settings. So you can manipulate that cure time, the base exposure, the layer height, and even the motor movements. And you can use that profile later on when you want to reprint with that material or continue developing it further. Our software also lets you know what kind of build plate to use. On a XiP desktop printer, you only have the solid build plate available, but we also offer a slotted version on our more industrial printers. And then we have a couple of printer properties here and advanced settings that you can use to make minor adjustments to your printer or to your build file before going ahead and hitting apply. So once I've applied all of the settings that I want for this particular build, it's going to go ahead and take me to the build area where I now have access to the left-hand side tools. You'll notice that these are actually grayed out right now, and it's because I don't have anything to work with in my build area just yet. So we're going to go ahead and go to import, where I can now import a model. Again, our software accepts .3mf files, OBJs, and STLs. And in today's case, we're going to go ahead and work with an STL. So I'm just going to go ahead and click on that three-way connector that we saved earlier, and I'm going to see that it pops up right here on the build platform. Now you'll notice that I have access to all of the tools, and I'll just go ahead and briefly go over them a little bit to give you an idea of what kind of tools you have to work with when creating build job. And these are also typical tools for most SLA printers as well. So if you're familiar with SLA, a lot of these are going to look familiar to you. If you're coming from the FDM side or you haven't been in 3D printing at all, these might be a little new. So if you have any questions, please feel free to ask them in the little question box. So the first tool that we have here is the transform tool. So if I was to click on my part, I have the option of transforming it, either rotating it, moving it around the build plate. On the right-hand side, I have freehand tools, so I can freely translate, rotate, or scale my part, or even duplicate it if I wanted multiple parts. Or I can use specific longitude and latitude points. I can rotate it about a specific point on the X, Y, or Z axis, or I can scale it either uniformly or non-uniformly. We also have a unique oriented base tool, which is very ideal if there's a specific base on your part that you want sitting on your platform. That's usually ideal if you have a very flat surface that you want to get printed out facing the build plate. And then we also have a couple of quick, easy access tools here, such as minimizing support area for the selected part or minimizing Z height for the selected part. So if you want minimal post-processing, the first option is very ideal. If you want your print to go by faster, then you would choose the second option. Next, we have support. So thankfully on this part, I don't need to add any supports to it, but if I did need to, then I have the option of choosing between pillar supports and scaffold supports. So the difference between these two types of supports is scaffold supports are extremely ideal for creating a really strong, sturdy foundation. And these are nice for parts that are long, tall, vertical, might tend to sway while you're printing. While pillar supports are very ideal for complex geometries or something that just needs a couple of touch points here and there. In the NexaX software, we offer you the ability to make minor adjustments to contact point, which is otherwise known as strength, or the amount of points that occur on your part, otherwise known as density. But we don't stop there. We also allow you full access to our settings. So if you wanted to completely change the lattice structure that you're generating, you have the option of doing that as well for both the pillar as well as the scaffold supports. You could then save these settings that you changed and you can create a profile that you can go back to later. So if you notice that with this material, I really like using this type of support, we don't limit you to just what we've already predetermined. You're definitely able to go ahead, make your own changes, save it, and continue using it later. We also have an edit tool where you can manually add support points onto your part. Or you can also brush supports away. Sometimes you have an important feature such as threads that need to be mated with another part and you don't want supports generating on them lest you get that post-processing and then suddenly the threading is not right. So we do have a brush removal tool that you can adjust the radius on and then brush supports away on your part. Another part that's unique to NexaX is what we call cones. So in the 3D printing realm, I'm sure a lot of us have faced the problem of warping, and warping sucks because you wait all day for your part and then suddenly the corners are curved up and you don't know what to do about it. So one thing that NexaX has to combat that is what we call cones. So this can also be achieved by using low strength, high density supports, because what it does is it really pulls on your part and keeps it from warping up due to thermal extremities or even sometimes those chemical reactions that are occurring with material. Cones are essentially just one really big, strong contact point. So it's essentially doing the same job as multiple support points in one general area, but this one's just a lot smaller and it's a lot more ideal to work with. You don't generate as much material also. So you can adjust the diameter of the tip as well as the base, and you could create it the way that you need to for your specific part. And then you just click apply, and that's going to go ahead and generate your supports. So from there, you can auto-generate your supports using the settings that you've determined, or you can also clear them. So moving on from supports, we also have our edit tool. So the edit tool is available in the Pro version, and this is one of those mesh editing tools that are ideal for parts that you want to manipulate a little further. So we have a repair tool, a hollow tool if you wanted to hollow out your part and add a lattice structure to it, as well as a perforate tool if you needed to add a drainage hole for whatever reason. Almost to the end here. I do hear our print has just finished up, so I'm just going to go real quickly over the rest of NexaX and we'll go ahead and take a look at that. So we also have a layout tool. So we have AutoNest, so especially ideal for dental labs that have a lot of those dental arches. The AutoNest feature is ideal for creating multiple builds or one build depending on the geometry of your parts so that it nestles it in an ideal way. And then we have array duplicate select, which if I was to create a build job right now, I would be able to create multiples of these three-way connectors and the X, Y, and even the Z. We also have an alternate flip version on our Z-axis stacking. So if you wanted to rotate your parts so that they're alternating, you can do that as well. Once you've created your Z stack, you can then go back and generate support so that your structure comes together and you can print it out. We also have an analyze tool. So if you wanted to just measure a couple of points on your part, you can do that. You can measure inner and outer diameters, as well as just 2 random points to get some distance that you need to measure. Once you're satisfied with the job that you've created, you can go ahead and save your job, and then you can send it over to your printer over the network, or you can save your build job to a USB drive and then print it out. Speaking of printing out, our job is done. So let's go ahead and take a look at it. I'm just gonna real quickly grab some gloves and pull that printout.
While Jasmine's getting prepared, I did want to point out again, one really cool feature about this software is the Z stacking. That's not a feature that you'll find very common with 3D printing software. So we can easily array in X and Y, and you'll see that a lot. But Z stacking is something that it's not common because it's difficult to achieve. And so we've worked very hard to make that an easy and intuitive feature for you guys, so that particularly as you look at producing multiple, you're trying to maybe go into like low volume production at the desktop or even industrial level, you can easily leverage the full build volume of your printer and not just that XY array.
All right, no, that is very true. Thank you so much, Louis, for that. So here we have it, everyone. We've got our 33-way connectors and X45 natural in just 10 minutes on the XiP desktop printer here at Nexa3D. So, I mean, it's really incredible what you could do with 3D printing these days. And honestly, sometimes you have downtime when it comes to having to wait for a part to come over. I mean, I think that we've one time had a downtime of about 45 days waiting for a part to come out to us. But instead of waiting, I got my parts in just 10 minutes. And that's just some of what you can do with the XiP desktop printer and just some of what you could do with the SLA printers here available at Nexa3D. So yes, thank you so much for joining our webinar today. I'm more than happy to go over any questions that you guys have. There are a couple more features on NexaX that I would like to go over just to give you guys just a little final overview of a couple of the features that are available to you. So I'm gonna go ahead and put this back real quick.
Thanks, Jasmine. Yeah, let's finish up that overview of NexaX, and then for all of our attendees today, take a moment and enter in all of your questions. I think we're doing just perfect on time, so we'll be able to get through everything that I'm seeing come through here right now. I'll turn it back over to you, Jasmine, and then we'll jump into the Q&A.
Of course. All right, so I'm just going to go ahead and finish up with NexaX here. So I've shown you how to create and send a job, which is one part of NexaX. Another part of NexaX is our Manage Printers tab. So we call this fleet management. So just because you have a desktop printer doesn't mean that you can't get an industrial type of setting out of it. So usually what happens is we have a couple of customers who will buy multiple XiPs, and we'll call that a XiP farm. And that creates that same industrial high volume throughput that you'll get with an industrial printer as well. And here under Manage Printers, you're able to add devices such as your XiPs, XiP Pros, your NXCs, and then you can manage them from your desk. So right here, we have an example. I've got Luna and I've got Leia. So these are the two printers that we have available over here in this room that I'm working in. Right now, you can see that they're idle, but if they were active and I clicked on these printers, it would show me a progress bar of how much time is left in the print. It'll give me a little bit more information about the print itself. So this is super ideal if I'm at my desk. I just want to see what my printers are up to, if I could start a print on one, or how much time I have before I need to go check on my print. Extremely ideal. And you can also send prints to queue from here as well. You could check on the history to kind of see what's been going on with the printers that you've been working with. So these are just some of the features of NexaX. This was a nice overall general overview of it. If you guys have any additional questions about the software, if you have any questions about the printer, I'm more than happy to answer them. So let's go on to Q&A.
Awesome. Thanks, Jasmine. Okay, we'll jump in here with some great questions. The first one I think is just fun. Can you please bring the parts a little closer to the camera so they can get a good look at what was on the build plate?
Of course, let me grab some more gloves real quick.
Thank you. And while she's grabbing those gloves really quickly, we'll go through some additional questions. The first question I see here up at the top is in relation to our industrial printers, so I'll answer that really quickly, and that is, what are the performance benefits or differences of a solid plate versus slotted build plate? So the difference in the slotted and the solid from a building standpoint in terms of like your parts and how you're able to leverage the build plate does not really change. The reason why we turn to the slotted build plate is particularly helpful for some of our more viscous resins, like our flexible resins, because it helps with the flow of the material through the build plate and back into the vat a little bit faster. And additionally, if you are working with anything that has maybe like a trapped volume, you might be concerned about cupping. It helps a little bit of relief in that area as well. So that's the primary benefit. With the ZiP, because of the build volume, we manage that quite well, and we're able to print with just the solid build plate without any issues at all. So there's no need for a secondary build plate. Okay, thanks, Jasmine. And we have another great question here. I think this is in relation to the Z stacking. This is coming, it says, how do you separate layers if you've printed more than one layer in the Z direction? Is there any additional post-processing steps required?
I'm sorry, could you repeat that question actually?
Sure can. So the question was, how do you separate layers if you've printed more than one layer in the Z direction? So basically, how do you address Z stacking from a breakout and post-processing standpoint?
Oh, so how would you go about post-processing a part that you've Z-stacked? So I think that you would go about post-processing it in the same way that you would go about post-processing a regular part. Normally, when you do Z-stacking, you do have stronger supports just because since you are going in a vertical direction, you want to make sure you're not getting any sway. So the supports might be a little bit more difficult to remove, but they are still easily removable, especially if you use something like snips. So I would say that there's not really, there might be some extra post-processing in the fact that your supports are a little bit stronger, but other than that, I wouldn't say that it's not a whole new world when it comes to Z stacking. Like you're still going to be familiar with that post-processing step. It's not very different, I would say.
Absolutely. And I would add to that, Jasmine demonstrated a really cool feature of the Z stacking, which is where you can like flip the part or mirror it almost. And so for an example, for this three-way connector that you see, if you look at how the part was oriented, you have the larger base oriented to the plate, and then there was the single cylindrical feature up at the top. So what we would do to minimize supports while still leveraging that Z-stack is we would flip that part so that you have the two single cylinders mating. The only supports that are required are to mate those two sections. And then similarly, mirror again, mirror again, mirror again up to the top. And you're ending up with a full build stack with very minimal additional supports at all. So it cleans up quite easily. All right. We have another great design and printability question, Jasmine. This one says, for designs that are long, to help prevent warping, would it be better for the design to be attached directly to the build plate, or is it better to utilize supports?
So I think that this is a really great question simply because there's a couple of answers to it. So one thing that I've learned when it comes to 3D printing is there's not always one right or wrong way to do something. There are multiple right and multiple wrong ways to do something. So in this case, you have the option and luxury of doing both. So you might have to do post-processing for both of these. So when you are printing directly on the build plate, you do have a higher base exposure to help with your part adhering to the build plate. And sometimes what that does is it'll create what we call an elephant's foot, where you'll get a little bit of over curing on the sides. So your part is for sure going to be sticking to the build plate and it's not going to warp, but you will have that additional post-processing there. You can technically get around that by using our base compensation feature in the custom settings, but that comes with the pro version. So there is that, but you can definitely still print a part directly on supports as well. So I mentioned that you have cones as an option, you have low strength, high density supports as an option. Usually you can go with that, and if that's not working, then you could print directly on the build plate. So there's a couple of ways to do it, and I wouldn't say that there's really a wrong or right way of going about it. It all depends on how you want to handle your part after it's been done printing.
Awesome. Thank you, Jasmine. Okay. Moving on to our next question. Oh, this is a good one. How do you clean and cure the parts?
Oh, that's a great question. Yes. So I like to say that 3D printing is 3 steps. It's creating your build job, it's actually printing your part out, but then there's a whole nother side of it, which is the post process, which is washing your part in a cleaning solution. Here at Nexa3D, we offer a cleaning solution called XClean. Typically, you'll notice that most 3D companies use isopropyl alcohol or IPA, and we use that as well. It's got a high evaporation rate, so it dries extremely fast, but it does have a higher flash point. So XClean, you can light a match, it's not going to blow the place down, thankfully. And it also is able to absorb more resin than IPA, so you get more uses out of it. So usually when it comes to post-processing, you would wash your part in a cleaning solution, be it XClean or IPA. Usually you could do 2 minutes on the build plate, so you also wash your build plate, or you could do it without. You could do 2 minutes in a dirty bath, 2 minutes in a clean bath, and then you can rinse the part in IPA, allow it to dry, and then you post-cure it. And so we offer what we call the XiP Wash and Cure unit, which is a 2-in-1 unit. You can use a bucket with cleaning solution to wash the parts. You remove the bucket and then you use a turntable. The unit does come with an LED array on the back. It's a 405 nanometer UV light array. And then you would cure your part for either half an hour, 20 minutes, or an hour, depending on the material that you're using. So that's usually the steps that you would take after.
Awesome. Thank you, Jasmine. I did want to add just a touch of color to that. So for the build that you just did, you said it's about a 2-minute wash, right?
Yes.
And then for the cure time in X45, could you give us a estimate of how long the cure cycle is for that?
For X45 natural, I want to say it's 10 minutes. So this material cures really fast. So some materials cure about an hour, such as XABS and XEE Black. Some materials are 20 minutes, such as Key Model Ultra, and then some are 10 minutes, like X45 natural.
Awesome. Thank you. So in this example, as you can see, even including the washing and the curing cycle, we're still under this 30-minute mark. So you're going from CAD to not just printed, but washed and cured part in 30 minutes, which is pretty exceptional for any resin printing. And then also wanted to highlight on the XClean material that we use for as our solvent for cleaning off the parts. So it has about 3 times the saturation limit of IPA and a lower evaporation. That means you're not losing it to the atmosphere around you, and also you can use it for 3 times longer than you would use the IPA. Obviously, there's also the benefit of it not being flammable because it has a much higher flash point. So that's a benefit, particularly in industrial commercial environments where people have to think about that. And because that is an issue, sometimes you think about procuring like vent hoods and things like that. So then it becomes this larger kind of situation around just cleaning your parts without an alternative solvent solution. So I'm really glad that we have that in our portfolio. Our next question here is going to be another one. What is the largest part size that can be printed?
So do you want to answer that one?
I'm happy to take that one. So really, you can leverage the full build volume of this printer. So that's going to be about 7.7 inches by 4.5 inches in the XY. And then our Z height is 8.3 inches. It's very sizable build volume for a desktop printer. I would encourage you to put that build volume up against even some of the industrial printers that you see out there in the market, and you'll notice that it is quite sizable in comparison at a much lower price point. Again, there's no issue with leveraging that full build volume, so you could build a ton of parts in that build volume or a single part, and it would take the exact same print time. And speaking of print time, this is another great question that someone asked. Jasmine, you said it takes about 10 minutes for printing, but the software in your setup said it was over 10 minutes. I believe I didn't look at it exactly, but it says 24 minutes right there on the print time.
Yes.
Could you explain the difference there? I think for our audience, it's a very astute question.
This is a very great question. And this is also, so the file that I printed, well, there's multiple answers to this one right now. So first, the file that I printed is actually a modified version of this. So I did mention that the part that I'm using is very similar to the one that I'm printing out right now. It's just a little bit shorter, but you are going to notice, despite even this height difference, that my print time was probably going to still be around the same amount of time. It was going to be showing here maybe 20 minutes or 15 minutes. So if I hover over print time, it's going to go ahead and say true print time available after saving job. So when you're creating your build job, that print time is going to show a higher build time than normal, or it might show a lower one depending on what features you toggle here in the job settings. So over here in the job settings, we have options such as large solid part enhancement and adaptive speed control. So these are two printer enhancement features that you can use that either slow your print down or speed your print up. So a lot of the times when you're creating a build job, you're going to see a print time that's higher than what you're going to expect. So see right here. So now my print time is showing that I have an estimate of about 12 minutes. And if I save this, it's going to be either about 12 minutes or 10 minutes. So my modified version after I saved it was 10 minutes. I believe this one, if I save it, would be about 11 minutes. So what happens is the software is calculating the geometry and the density of your build, and it's applying adaptive speed control. So if I was to explain adaptive speed control as quickly as I can, it's essentially an algorithm that takes into consideration the density of your build and the different cross sections, and it slows the motor movement down accordingly to increase the chances of your print succeeding while printing. Because essentially in SLA, you're peeling away layer by layer, and that peel is usually where you get a lot of failure. So adaptive speed control is meant to combat that. So that's why you see a difference in the print time. So once I save my part, it's going to show me a true print time, which is going to be about 10 to 11 minutes.
Yes, and to expand on that a little bit, we've built, as Jasmine said, we built a lot of intelligence into the print engine. So, you know, our hallmark is ultra fast 3D printing, and we want to make sure that that's a reality for you guys, whether it is, you know, a few small parts or a larger part. The best way to do that, you know, especially as you're starting to learn the technology, is through having the adaptive speed control turned on. And so as you get to a large cross section, you don't have to worry about it. The printer will take care of managing that layer and slowing down the print while it does that larger cross section. And then as you get to a thinner cross section, it'll speed right back up. So it's a fantastic feature. And then next question that we have here, is there any information on wash and cure times per material? Yes, there is, and that is provided to you guys both at the time of purchase and installation, but also readily available on our support site at any time. There's a nice little downloadable as well that you can leverage if you would like to keep that around and easily accessible. Then, do you need to vent the XiP desktop machine to the outside? So if you look at venting, again, for the XiP, and especially because we don't require you to use IPA and you can use the XClean, no venting is required. It's a really office friendly tool. It's regularly installed right alongside a lot of designers and our engineers and all of that. If you, some people tend to be more sensitive to resin profiles in general. And so in order to combat that as well, we've actually developed the XiP Air. So it is a air purifier that you can put right next to your XiP if you'd like, that will help remove any VOCs or anything like that. It has a special filter in it with a carbon level that's about 5 times higher than what you would normally get out of the typical air filter that you would buy off of Amazon or something like that. So it really helps to capture all of that and make sure that you have a pleasant office environment. It's a really easy addition and a part of our standard XiP package as well, if you decide to go down that route. So it's a fantastic tool. And then for our next question, we have, how does the machine handle large, thick, solid parts such as mold inserts? Will they tend to warp more? I think that's a great question that Jasmine covered already with the large part the adaptive speed control feature. What I did want to highlight here is specifically for mold inserts, we actually have a resin called XMold that is developed for injection molding, so 3D printing injection molding tools. So that one is, we have a lot of experience with molding, and we would recommend that for any sort of molding applications. But in general, that adaptive speed control is going to handle those large, thick cross sections quite well. Jasmine, is there anything you want to add to that?
Yes, so I have printed out a couple of mold inserts on our printers before, and you're right, they are a little bit more difficult because they are so sizable. So like Lewis mentioned, there is the adaptive speed control, but I wanted to highlight the large solid part enhancement, which is really ideal for these types of parts. Large solid part enhancement takes a very large cross section and it pours it into an inner and an outer shell, and then it cures it separately so that you're avoiding a lot of those thermal extremities happening, because it's usually that generation of heat that causes warping, because printing with resin is an exothermic reaction. So large solid part enhancement is really ideal for that. But on top of that, you also have the different types of support settings you can use. So if you are printing your mold on supports, you do have cones that you can also utilize to really hold your part down and avoid warping up in the corners. So there are a couple of features on NexaX that are available for helping optimize print success for molds. And then we also have XMold.
Thanks, Jasmine. Okay, cool. Other questions? With resin printing, at what point in the full process from print all the way through to wash and cure, is it recommended to remove supports?
Oh, wow. That's a pretty good question. So typically the workflow that I would say to use is to remove supports during the wash process. So the reason why is because sometimes you'll get resin around those touch points where the contact tip is between the support and the actual part, and that could trap resin in there. So you want to remove your supports while washing so that you can get all of the resin off, because when you go from wash to cure, you want your part to be completely dry and resin free. However, there are some instances in which you might want to keep your supports on your part, and that is if your part is extremely prone to warping or it's a very delicate feature and you want to make sure that it doesn't warp during the cure process. Usually that's if it's an extremely thin feature. And in that case, you can wash your part as well as you possibly can. You can use a couple of tools. You can try to use an air compressor to try and blast some of that material out of the area around the contact points, and then you could cure your part that way as well. So it is dependent on the application that you're trying to achieve, but for the most part, we recommend doing it during the wash process.
Thanks, Jasmine. And then another question here, will the supports show in NexaX?
Yes, so the supports will show if I generate them in NexaX. And from there, you'll be able to edit them. In the edit feature, it will show up as just contact points, as little white dots, but we do have options where you can show support, so you can see what exactly you're editing, what lattice structure you kind of want to change. So yeah.
And in our advanced settings, she showed you can use the brush tool to erase unnecessary supports if you think it'll build fine without it. You can also change the contact width, the support density, all of that to help, one, make sure that your part is properly supported and built well, but also as you gain confidence in the printing process, really understanding how supports work to help you achieve, a successful print. You can also start trialing things with support density or contact tip diameter so that you can mitigate the amount of material you're using for supports. That'll help reduce material consumption and overall cost per parts, stuff like that as well. So it's a bit of a learning curve, for any sort of resin 3D printing. I think within NexaX, they've done a great job of making this very intuitive. And so as you gain a little bit of confidence and experience, and it won't take long, you'll get the opportunity to experiment with a lot of those tools as well that can be really helpful. And our next question, are there any parts that can be printed without any post-processing steps? Can we simply push print and get the part ready to use? That's a good question.
It is. Unfortunately, you are going to need to do some amount of post-processing. So the post-processing steps typically include removing supports, washing your part, and curing your part. So washing your part is extremely essential because when your part comes out of the printer, it still has uncured material around it because it was being dipped back and forth inside a resin vat. So you are going to need to do that part at the very least. When it comes to removing supports, if you don't have supports, that's one less post-process step. And then when it comes to curing your part, so when you're printing your part out, you aren't curing it 100% of the way. Post-curing it allows the part to reach its full mechanical and material properties that are offered and shown in the technical data sheet of that material. So I suppose if you don't really need all of that material property, you could get away with post-curing it less, but I would still highly recommend that you wash and cure your part. So I wouldn't say that there really is like a right out of the printer way of getting a part, unfortunately.
Awesome. Thank you, Jasmine. Okay. How often do I need to change my XClean solution? And lots of great post-processing questions. I love this. How often do you need to change XClean solution? And how do I understand when do I know whenever it's saturated enough and I want to swap that out?
So that is a really great question. So with XClean and with any cleaning solution, a lot of the times there's a couple of checks that you want to look for. The first one is visual. So if your material is visually looking very heavy, very dense, very muggy and foggy, that's usually an indication that, okay, I need to start taking a look at this a little closer to see if I need to switch out the material in here. There's also, when you're washing your parts, you'll notice that you have to wash your parts a couple more times or for a little bit longer than normal to get it completely clean. So there's a couple of initial checks such as that, which will indicate to you that, okay, my XClean or my cleaning solution is starting to get very saturated. With XClean in particular, you can use a device called a hydrometer to measure the specific gravity of the material. So you're looking for something within the range of 0.91 to 0.95, I want to say. We do have more specific numbers available on our support site for this. But usually it's a visual check. So if your cleaning solution looks like it's getting dirty, it's time to start keeping an eye on it. If your parts are taking longer to clean, then that's usually an indication that you're starting to build up a lot of density inside your cleaning solution. And then the final step would be to use a hydrometer to measure the actual specific gravity.
Awesome. Okay. We have a lot of questions coming in. I'll stay on as long as we want to go through this. There's some great ones here. I'm going to switch up from post-processing just a little bit. So the first is, how easy are parts to remove from the build plate? So what is the removal process from the build plate?
So generally, I would say that parts are fairly easy to remove from the build plate. So the build plate is an anodized aluminum. It is a little soft, so you do want to be a little careful when you're removing parts so that you don't gouge it or create any hills or burrs on it. Removal is quite easy, but if you do notice that you're having a difficult time having parts removed from your build plate, we do offer, again, in our job settings menu, there is what we call an advanced setting here. This is available in the basic version. In the custom version, you can actually go through and you can see the actual base exposure time and adjust as needed. But if you notice that you're having difficulty with parts adhering to your build plate, either it's too strong or it's not strong enough, you can always adjust it here by a factor of 15 to 30%. But for the most part, in general, it's pretty easy to do. You just knock them off with the spatula and they come off very easily.
Awesome, thank you. Okay, this is a really great question. This says, can you speak to the general tolerance specifications for the XiP Pro? Currently, Xometry is offering your machines services and say it's only capable of plus or minus 5 thousandths in XY and 10 thousandths in Z. Is that correct? So, you're talking luckily to a guy who spent the last 12 years working in the service bureau industry. And so what you have to understand about the Service Bureau is they have to plan for the rule and not the exception. So basically, they don't know what they're going to make. They have to be prepared to make a variety of different parts, and then they have learned to do that exceptionally well. But whenever you are developing a process that has to accommodate basically anything and everything that might come their way, you have to limit maybe like the potential capabilities of a platform that you're using. So as you look at XY resolution, specifically as it relates to our technology, any of our printers on the resin side are going to be limited in XY based on the pixel size. That is your XY resolution specifically. So for the XiP Pro, we are at 46 microns in terms of a full pixel. So that is rather tight and very, very tiny. So that's, I would say, a pretty good resolution there. And then we have some integrated anti-aliasing technology for, curved edges, things like that, a part that might sit through, like, a quarter or a half of a pixel or something like that. We can actually achieve sub-pixel resolution by grayscaling that pixel and get down to about 26 microns for that pixel. So as you look at trying to build this part, every geometry, looking especially at things like Jasmine just talked about, exposure time, stuff like that, the longer you expose, the growthier the part's going to get. Based on the pixel size, that's going to change your XY resolution. So for the XiP Pro, you would definitely be able to get a finer resolution than what you're seeing there stated from Xometry. So that's kind of the difference between printing it yourself and sending it out to a service bureau. And you'll see that's pretty common regardless of what service bureau you go to or what technology you use. They're always going to have these minimums, both in tolerances and capabilities. They're going to be slightly broader, more expansive than what you would see the capabilities as presented by the manufacturer. And it's for that reason that they have to be able to accommodate any and every geometry. Now, in relation to the Z direction, that's going to be dictated by your layer height. So our standard settings are dictated by resin and the resin profiles that we've generated. That's typically going to be anywhere from 50 micron layers to 100 micron layers to 200 micron layers. And so some of our resins have multiple settings. Some, like our dental resins, are very finely tuned into either 50 or 100 microns. And then we have draft modes for a couple of resins like our X45 or X ceramic, and those are really generated at pumping out a part fast while still maintaining a high degree of integrity in the part. So there's a lot that you can do there. And again, if you have the printer yourself, you can dial that in. All of our printers are capable of printing down to 25 micron layers. You would just need to create a custom resin profile at that Z height. And anytime you change your Z height, that is going to affect print time, because that's basically you're changing the number of layers. So if you go from 50 microns to 100 microns, you're cutting the number of layers in half. From 100 microns to 50 microns, you are doubling the number of layers required for that part. So that's just how that works within resin systems. So hopefully that answers your question. Another one, this is a nice softball and one I'm really excited about, so thank you. to our attendee for this. But what is the price of the ZiP package? 3D printer, wash and cure. So that entire package is just over 8K. But actually, we just introduced a package that's available through the end of the month, through the end of the quarter here, that's going to include the printer, a ZIP Air, a 3-pack of membranes, 2 starter resins, X Model 15 and X80S, a wash and cure, and the 1-year Evercare service plan, and a 1-year free license of our advanced NexaX Pro for ZiP software, all for just under 10K at $9,995. So I think that's a really exceptional deal. We're excited to offer that to the end of the quarter. And if you have any questions, feel free to email me, or I can reach back out after this to give you more details on that. Okay. How do you refill, oops, sorry, Jasmine, how do you refill resin mid-print? This is a great question because we have a solution for that.
Yes, we do. So inside the printer, there are 3 components that a customer is going to be using when they're working with it. There's the resin vat, there's the build plate, and then there's also the resin cartridge. So the resin cartridge is 1 kilogram of extra material that a user can use during a print. And I'm going to see if I could do this from here, but on the top side of the printer, there is a little opening so that you can actually remove the cartridge and reinsert it. And you can do this before a print or during a print, and it's not going to affect your print at all. So if I was to show you, you would pretty much just be taking that cartridge out. You can refill it, and then you could insert it back in, and it doesn't affect your print at all. And you just continue printing with more material.
Absolutely. And that cartridge is gravity fed, so that actually helps keep a steady state level in your vat at all times. So as you're consuming resin, it'll backfill with fresh resin to keep it at that steady state level for printing. So, utilizing gravity to solve some problems for us, but it's a really great feature as you look particularly at some longer prints.
Yep, we love physics.
Okay. This is a good post-processing question. I apologize for a little bit of the background noise here, but when curing, how are non-visible areas treated?
Oh, that is actually a very good question. So the way that I would say curing works in general is that UV light is penetrating your part all the way through. So it's not just affecting your outer surface, it's actually going through your part. So that's usually why and on top of that, in our 2 cure units that we offer an X cure, which is a larger size cure unit, and then we have the ZIP wash and cure, which is the 2-in-1. They also have reflective sheets on them so that you're getting UV light hit at every angle. So you're getting UV light evenly distributed throughout your part. And then on top of that, the UV light is also penetrating into your part a certain amount. If you have an extremely large part, like very thick walled, very large, then you might end up needing to cure your part a little bit longer for that penetration to be effective. But for the most part, the unit is designed in a way, and the science of it works in a way that your part is getting penetrated with UV light. So even those like parts that you would think, oh, that's not getting hit, they're actually being exposed to UV light as well.
Sorry, they're just writing a typed answer back there. Okay. We have, there's somebody. No, this is a really good one. Okay. When you switch resin material, are you required to change the membranes?
That is also a very good question. So typically our membranes, they last about 50,000 print layers, and that is plus or minus depending on how the membrane is handled during its lifespan. When you're changing materials, you don't necessarily have to change membranes with it. If you're going from a black material to a white material, it might be most ideal to take that membrane out and then thoroughly clean it around the gasket to ensure there's no excess resin left on it. But you don't necessarily need to switch and keep one membrane per material. They can be used across multiple materials.
Okay, great. Thank you, Jasmine. And okay, we still have several questions and we are coming close to our time. So I'm going to do a little bit of a rapid fire here. The first question was really regarding, can you change the density or infill? So I'm assuming your experience previously with 3D printing is largely with an FFF or FTM based process where you have the filament and then the extrusion process, and you can change density and infills based on where the extruder goes and how often. So this process does not have any sort of an infill process where you can, kind of change what that looks like. So that'll be a little bit different. It's just kind of curing and solidifying all at once. Jasmine, is there anything you want to add to that?
No, I think that you hit it pretty well.
Thank you. And then, oh, this is one, Jasmine. I think I understand where they're going with this, but I'm going to throw this one to you in case you interpret this differently. But it says, are all of your materials IPA soluble?
Soluble. So
I,
I'm an
I
engineer, not a
think,
chemist. So I think what
I think the intention is, can they all be cleaned with IPA?
I'm
Yes.
guessing that's what it is as well. And yes, so all of our materials can be cleaned with IPA. If anything, so I mentioned earlier that we offer XClean as a cleaning solution as well. So we offer biocompatible materials. Those ones are the only ones that have special cleaning requirements that can only be used in IPA. But other than that, all of our parts can be used with IPA.
Great. Another one said, can you still use the stacking feature of the printer in a short time, 30 minutes or less? Well, you can stack whatever you'd like, but it is going to be dictated by the number of layers that it's printing. So for example, with the geometry that Jasmine used, it was 10 minutes for one layer. So if you multiply that by 3, you'd get about 30 minutes, and that would get you maybe halfway up the build plate. But you would not be able to do a full build in 30 minutes at that point. Now, other parts, and particularly if it's thinner cross sections, stuff like that, you can move a little bit faster there if there's not a lot of supports. But that's a general rule of thumb. It is just really following that layer speed and trying to do what you can to speed up that process if you want. Our XiP Pro is like wicked fast. It can print up to 24 centimeters per hour in our fastest printing resin. So if you do the math there, you can see that its output is extremely high. So the XiP is somewhere around 18 centimeters per hour per vertical hour, or 18 vertical centimeters per hour. Sorry, it's been a long day already. So still very fast, but it's geometry dependent. I would recommend doing this. We actually have a really cool tool online too, if you want to kind of play around with NexaX, maybe estimate costs and what this would kind of be like for you to use. We have our online cost simulator tool, and it looks almost exactly like what you see here, where you can upload an STL file, you can choose what material you want, and the only difference is it's not going to let you customize settings. It's going to give you basically our set it and forget it, standard validated settings without any further adjustments. It'll give you the total estimated print time. It'll give you the number of layers, and it'll give you the cost per build and cost per part. So it's a really intuitive, cool tool that I would recommend you use. As Jasmine illustrated earlier, that estimated print time without any adjustments, that's going to be kind of like your maximum right there. So I would expect if you, whatever you see there, that's kind of your maximum, and there's the ability to bring that time down quite a bit depending on your needs. So I did want to point that out to you guys. Another question was around biocompatible resins. So on the biocompatible side, we do have dental resins that are used for dental applications as well as general medical applications that you can leverage for those applications. When it comes to biocompatibility, if this is a biocompatible resin, yes, you also need to look at the application. Where is it being used? What level of biocompatibility is it assigned? And for what length of time? is that are validated for biocompatible applications. And I can imagine that we see this in the future as well. And another great thing I want to point out about all of our resin platforms, or all of our platforms in general, is that they're open source. So we do not limit you to just our resins. So if there's another biocompatible resin, as long as it's compatible with our wavelength of production of 4 or 5 nanometers, you can use it in the printer, no problem. There are a few questions left here. I'm so sorry, but we're at the time. I'll be sure to follow up with you guys and make sure that you get the answers that you need. But I wanted to thank you for your time. I hope that this is a demonstration that taught you a lot, let you know a little bit more about our product, got your questions answered. This recording will be available on demand in the next 48 hours. So feel free to review that again, or share with any of your colleagues. They're more than welcome to view that as well. I just want to say thank you for your attendance. And if we don't speak between now and the end of the week individually, have a wonderful holiday weekend and a great Labor Day.